All right, find the indicated value if it exists. So now since everything goes back to sine and cosine, if you memorize sine and cosine, then if you just start out with everything in terms of sine and cosine, it's really easy to find them from there. So I would recommend to just take secant and change it to, it would be the reciprocal of cosine, right? So the reciprocal of cosine. So cosine of 60, I think that's the one that's 1/2, isn't it? Check your chart if you don't have them memorized yet. So 1 over 1/2. Correct me in the chat if I'm wrong. So 1 over 1/2, the reciprocal of 1/2 is 2. So the secant of 60 should be 2. Okay, cosecant. So for cosecant, we're going to do 1 over the sine of 7 pi fourths. So the sine of any pi fourths value is square root of 2 over 2. But 7 pi fourths is in the fourth quadrant, I think. Draw a picture if you need to. So 7 pi fourths would be like here. And so sine would be negative. So that would be negative square root of 2 over 2. So the reciprocal of that would just be negative 2 over square root of 2. Now actually, there's a more simple answer than that. It's just that if you use that sign and memorize it this way, then that's what you would come up with, and it's not wrong. Let's do just a little side note about that simplifying process though. Technically, when we first learned about these, sine would be 1 over square root of 2. We just rationalized it and turned it into square root of 2 over 2. And so that means that cosecant would be square root of 2, just the reciprocal. So just flip that over, so it's over 1. So I guess what I'd like to show you is that this thing right here really does equal this, because that is definitely the more simple answer. So negative square root of 2 over 2, if we rationalize that, we would multiply by square root of 2 over square root of 2. So that would give us negative 2 square root 2. And then when you multiply square root of 2 times square root of 2 together, that's what rationalizing, that's why we do this, so it'll rationalize it. But now we have a 2 on the top and the bottom, and we can just rewrite this as negative square root of 2. So that seems rather bothersome, honestly, in this particular case, to use the sign, the reciprocal of the sign, to find the answer, or it also seems bothersome to have done the rationalized answer of this in the first place, because you just flip it over and it's just more simple that way. So anyway, just some things to think about and issues to deal with, knowing that if you put this answer down, technically you're right, it's just not rationalized. And I guess it could get marked wrong depending on where you're using it, but if it's the right answer and it's just like a written, so like on a Canvas-driven multiple choice type of test, if you didn't see your answer and it was this instead, that might mess you up, right? But if it was a written test and you wrote it this way, if I was grading it, I don't think I would dock any points. I would just put a note that says, oh, rationalized would be this answer. So anyway, that was a long explanation for stuff on that. Okay, let's go to cotangent. So that would be 1 over the tangent of 3. Now, this is not on our chart. 3. It doesn't have degrees, not that it would have mattered if it was degrees, but because it doesn't have degrees, it just means it's in radians. So you either use a calculator that will do cotangents for you, which I don't even think those are allowed. Basically, most calculators only let you do sine, cosine, and tangent. You need to make sure your calculator is in radian mode. I think we talked about that in class, so if you need help with that, let me know. Make sure your calculator's in radian mode, and then go ahead and type in your calculator 1 divided by the tangent of 3, and it should give you an answer. So let me try it and see what I get. So 1 divided by the tangent of 3, although I know my calculator's in degrees, so let me change it to radians. And do the same exact equation again, and I got negative 7, negative 7.02. I don't even know how many decimal places I should do, but I feel like I owe it some sort of decimal place since it's not exactly negative 7. So something like that. Start my video again. Here we go. Alright, number 4. Tangent theta, where theta is any angle coterminal with 3 pi halves. So I'm definitely going to sketch this. So 3 pi halves is here. So that would mean that our x value is 0 and our y value is negative 1. So tangent theta, where theta is any angle coterminal with 3 pi halves. I guess what they're trying to say is if it was tangent 3 pi halves, great. But if it was tangent 5 pi halves, it'll be the same answer. Or if it was tangent of negative pi halves, it'll be the same answer, right? So just keeping that coterminal thing in mind, that you're going to have the same answers for sine, cosine, tangent, and everything else if it's a coterminal. Okay, so for tangent, we just learned that it would be, so now it's really feeling more laggy. Oops, I was just going to write theta. Started writing more than that. I don't know why it's getting so laggy all of a sudden. Okay, tangent of theta would be y over x, and y is negative 1, and x is 0. Oh, what does that mean? We can't divide by 0. When that happens, we call it undefined. So the tangent of 3 pi halves is literally undefined, as is, I can't spell, undefined, as is the tangent of pi halves. So tangent is undefined at every increment of pi halves. So you could even call that k pi halves, because it will be undefined when x is 0, which happens at 90 degrees and 270 and anywhere around positive or negative to those two angles. Okay, cosine. Cosine theta, where cosecant is the negative square root of 5 and theta is quadrant 4. Okay, so we don't care exactly where the angle is, it's just quadrant 4. I usually sketch it just to keep that in my head. Cosecant is the reciprocal of sine. So knowing that the cosecant of theta is negative square root of 5 tells us that sine is negative 1 over square root of 5 because it's the reciprocal. Well, we are asking for cosine, not sine, and cosine in quadrant 4 is positive. So this goes along with the problems we were doing last time at the end of class, so I think it became one of those videos that hopefully you watched later, and that is using Pythagorean identity to solve these. So we would use sine squared theta plus cosine squared theta equals 1, so that means we would do 1 minus sine squared theta. Oh, it's not quite as bogged down, but as soon as I started to think that, then it bogged down again. Okay, so it'll be the square root of 1 minus negative 1 over square root of 5 squared. So that would be positive 1/5. So then 1 minus positive 1/5 would be positive 4/5. And then the square root of positive 4/5 would be 2 over the square root of 5. You could rationalize it if you want to, but I'm not going to. So since we know cosine is positive in quadrant 4, that's the cosine. If it was a different quadrant where cosine is negative, then we would have to make sure we get a negative answer. All right, let's do this one last one. Sine theta, where the tangent of theta equals 3, and it's between pi and 3 pi halves. So that's telling us quadrant 3. That's what this tells us right there. Okay, here's the other thing that I think they've thrown in here to confuse us. In this problem here, we did the tangent of 3. We were plugging in 3 as the angle in radians to find the ratio. But in this problem, 3 is the ratio. And so that 3 is equal to our like y over x, not to an angle. And that means it would be like 3 over 1, right? So if we sketch our own little triangle here, that would be the y value is 3, but look how it's going downward, so that would be a negative 3. And then the x value would be 1, but that's going to the left, so that would be a negative 1. And we don't even care, well, we actually do care what the hypotenuse is. So we need to know what the hypotenuse is so that we can find sine. So we're going to just use Pythagorean, not identity, but Pythagorean theorem, super fast. So that would be, we want to find c, we've got 1 squared and 3 squared, so that would be 1 plus 9 is 10, and so c would be the square root of 10. Hopefully that made sense without me writing out every teeny little detail. So that would be the square root of 10. And so therefore the sine of whatever this angle theta is would be opposite, which is negative 3, over hypotenuse, which is the square root of 10. So tangent was positive. That didn't mean it was quadrant 1. And they told us the quadrant by doing this, quadrant 3. So therefore we know both the sine and the cosine are negative. That's why I sketched it in quadrant 3, paid attention to the directions and the negatives, found the hypotenuse, and there's my answer.